This ongoing research examines the temperature of cables that are grouped together and cables that are installed in thermal insulation. To test the wiring methods used in residential buildings, we designed a wooden test structure with a peaked roof to simulate a typical residence. We began by testing the cables in thermal insulation. We moved to groups of cables that penetrate wood elements. We then examined cable groupings installed in fiberglass bat insulation and buried in various other types of insulations.
We're looking at a load bank. These pipes contain 4 conductors, each pipe. They are number 12 XHHW conductors, and what we do with these conductors is connect them end to end to form one continuous circuit. That means there's so much resistance in the circuit that we can use this as a load. Rather than using a motor or some light as a load, we have a known quantity. I can make the load 15 amps, 20 amps, whatever I'd like with this. I can also use this as a ballast to adjust my automatic regulating current controllers to any value that we need it to be. The circuit that supplies the experiment is a linear circuit. It's a single loop. Therefore, if we establish a current, say 10, 20 amps, then that current flows through all of the conductors in the experiment, all of those connected to the experiment. This way we can do an apples to apples comparison of the different installations and come away with some knowledge of what the relative temperature at a given current is. We found that the controlling the current to a circuit under test can be challenging. Our static variable current controllers were not allowing us to keep up with the differences in temperature and resistance of the conductor as the item is going through test. So to improve that, we found automatic acting current controllers controlled by DC voltage. We then found some PID controllers that, when connected through current sensors, can be programmed reverse acting to cancel out any deviations in the current. They react by sensing current that is going through the test circuit. If they see the current going down, then they automatically adjust the voltage to the controller up to compensate. We have been able to achieve 5% accuracy with this. Data is collected in 5 to 15-minute intervals. It is requested by the data logger. The data logger is connected via a pair of cables to the multiplexers that are located in the residential building, and those multiplexers are then connected directly to the sensors. This particular wall is south-facing. This means that the sun will hit this wall most of the time. Well, the other wall is north-facing. So it provided us a perfect example of what happens when the sun hits an exterior wall to the temperature of the wall cavity, including the conductor itself and the load on the conductor. And additionally, the north-facing wall gives us the idea that if a conductor is to overheat, it's not going to be because of solar. The outdoor ambient temperature could be low in the 80s or 90s and no sunlight on the exterior wall. And so if we do get overheating in a conductor on that wall, you can be pretty certain that there's a problem. As far as temperature of the room is concerned, we keep the temperature between 72 and 76 degrees at all times, so that when the experiment's running, that will not be a factor or something that might disturb the experiment. We also have the terminations in the air-conditioned space so that no temperature can be communicated from one experiment to the next. This particular examination, this one and the one below it, are similar. There are 12 cables in the group, 24 conductors. There are sensors that are placed in the opening in the framing. And this particular one has not been sealed with any kind of insulation, but this one has been sealed with fiberglass bat insulation to imitate that code requirement that we would seal periodically or draft stop openings in framing. We did a study with 5 different examples, one of them with air, one with bat fiberglass, one with chopped fiberglass, one with chopped cellulose, and one with expandable liquid foam insulation. This one is the one with the air. You can see from this one that we have a number 14 NMB cables, and this particular grouping of cables is 12 inches long. It has sensors in the middle inside, middle outside, the top and above the top. We also have a single conductor, which is on the other side of the wall cavity, and it has sensors at the center and the top, similar to the location in the bundle. This arrangement is identical to the rest of the wall assemblies. Again, the batt insulation, batt or the chopped fiberglass, chopped cellulose, and spray foam insulations. In this particular grouping of conductors, you can see how we have attached some of the thermocouples. You see they're attached to the outside of the jacket of the NM cable, and then the ones that are designed to be in the center of the grouping are then sort of placed in the center of the grouping. We have them in the center at the end, and in this particular installation we have bundles spread apart, and we have sensors at 2 inches going away. The purpose of this experiment was to determine how far the temperature would carry away from the main grouping of the bundle. So, and we found out that it drops off relatively quickly. The conductors in this experiment were loaded to various percentages of their allowable ampacity. We loaded them incrementally from 0 amps up to 125% of their allowable current. In most of the experiments, the NM cables exceeded the 194F that is allowed by the NEC. Then we looked at the resulting cable temperatures from currents that were below 80% of rated maximums. The code allows a conductor to be operated at 80% of its maximum load current indefinitely, 24 hours a day, 365 days a year. Even though some of the conductors were loaded to a lot less than 80% of their rating, a temperature of 194 degrees F was achieved after only a few hours. The code also allows a conductor to be loaded to 125% of its rated ampacity for 3 hours or less. When we tested with 125% of rated current, we found that most of the conductors and most of the thermal insulations, except for air, exceeded the 194 degrees F allowed by code, and in a lot less than 3 hours.